The unit circle. So this unit is a review of what you learned last year, and some of you may even recognize this worksheet. So hopefully this will kind of jog your memory about the unit circle, which is very important to mathematics, and it's going to be important that you have it memorized, which we'll talk about. A unit triangle is when you have a triangle whose hypotenuse is 1 unit length. To convert from our special right triangles to unit triangles, you must divide all 3 sides of the triangle by the hypotenuse and rationalize the denominator when necessary. Recall that sine ratio is the ratio of the length of the opposite side to the hypotenuse in a right triangle. The cosine ratio is the length of the adjacent side to the hypotenuse. So remember, we have our SOHCAHTOA. And so we talked about sine is the S, is the opposite over hypotenuse. Cosine is the C, which is adjacent over hypotenuse. And tangent, which um, is the T, is opposite over adjacent. So we talked about these in Math 1, 2, and 3. And so that's what we're talking about right there. The side length relationships for a 30, 60, 90 triangle and 45, 45, 90 triangle are shown below. So here is our 45, 45, 90 triangle. So it's 1, 1 root 2, which we've talked about before. And for this, we talked about last year doing the conversions. So if we want a unit triangle, we divide all of these sides by root 2. And of course, when you divide by roots 2, you don't want to leave your fractions like this when we're upper level math. You want to rationalize the denominator. So to rationalize this, we had to multiply both the numerator and denominator by roots 2 over roots 2, because that gets rid of the radical in denominator, because root 2 times root 2 is the square root of 4, which equals 2. So that's where we get root 2 over 2, root 2 over 2. And then, of course, if we have the hypotenuse, which is root 2 over root 2, that's just equal to 1. That's how we get our unit triangle. So for this one, we can do the same thing for our 30, 60, 90 triangle. Now the hypotenuse, again, which is across from the right angle, is 2. So if we divide all of our sides by 2, we end up with 1 for the hypotenuse. And that means this is going to be 1/2, and this is just root 3 over 2. And we use these unit triangles, remember, to help us with our unit circle, which we'll get to in just a minute. So recall that there are 360 degrees in a circle, and we also talked about last year there are 2 pi radians in a full circle. Label the circle below using degrees from 0 to 360 and in radians from 0 to 2 pi, counterclockwise starting from the positive x-axis. I've started this for you, so go ahead and do this part on your own, and when you're done you can unpause and we'll go ahead and check it. Recall to convert degrees to radians, you can multiply by pi over 180, and remember to always leave your radian measures in simplified fraction form with pi. All right, so hopefully you've already filled this all out, so let's go ahead and look at the degrees. So we know that if you look right here, this is the first triangle that we talked about last year using 30 degrees, and then the next triangle, which would have been this one, uses the 45 degrees. And if we were to do another triangle here, that's using the angle here as 60 degrees. So that's why we use those unit triangles. So if this one is every 30 degrees, you could count by 30 degrees to get those if that helps. Just kind of giving you guys some tricks to think about. So this is 30, 30 plus 30 is 60, plus another 30 is 90. That gives you 120. If you add another 30, we get 140 plus another 30, 180. So if it helps you to count like that, and then of course we know you could also count by 45 degrees. So if this is 45, 45, and 45 is 90, plus another 45 here would give you 135 degrees, or you can notice that the relationship in between each of these is 15 degrees, whatever helps you to get them around your circle, and you should be able to go around the circle fairly quickly. It shouldn't take you very long to do the degrees. 240 degrees. Down here we have 270 degrees, 300 degrees, 315, and 330, and then back around gives you 360. And then, of course, we also talked about the radian measures last year. So for our radian measures, we are starting with 0 radians and then pi over 6, pi over 4, pi over 3, pi over 2. So for this, notice that just like the 30, you can count by 30 degrees each time. You can count by pi over 6 so, and then reduce. So this is 1 pi over 6. This would be 2 pi over 6. So 2 pi over 6, notice when you reduce that, that gives you pi over 3. So 1 pi over 6, 2 pi over 6, this is 3 pi over 6. When you reduce that, notice it gives you pi over 2. So this would be 4 pi over 6. And when you reduce this, this gives you 2 pi over 3. And then this would be 5 pi over 6. And then 6 pi over 6 is just pi. 7 pi over 6 isn't going to reduce. And then we have 8 pi over 6, which reduces into 4 pi over 3. This would be 9 pi over 6, which is 3 pi over 2. 10 pi over 6, which is 5 pi over 3, and this would be 11 pi over 6. And if we went all the way around, this is 12 pi over 6, which of course is 2 pi. So that's an easy way to remember the radians with pi over 6 all the way around. You can just count. You can do the same thing, of course, then with the 45 degrees. So 45 is pi over 4. So this is 1 pi over 4. And then notice from here to here is another 45 degrees. So instead of using pi over 6, I'm just going to go ahead and use 1 pi over 4. This would be 2 pi over 4, which of course reduces into pi over 2. So that means this would be 3 pi over 4, which doesn't reduce. And this one, instead of 6 pi over 6, this would be 4 pi over 4, which again is pi. 5 pi over 4, which doesn't reduce, so we can just put that here. This one would be, instead of 9 pi over 6, we would have, we're doing 5 pi over 4, so this would be 6 pi over 4, which again reduces into 3 pi over 2, and this would be 7 pi over 4, which doesn't reduce. And then over here, this would give us 8 pi over 4, which gives us the 2 pi to go all the way around. So notice we counted by pi over 4. So 1 pi over 4, 2 pi over 4. This was 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. So it's just an easy way to remember the radians instead of having to always multiply by pi over 180 to go around your circle. So that is something that you need to be able to do fairly quickly, and not only in the positive direction, but also the negative direction as well, which we talked about last year, that if you go the other way on the unit circle, which is clockwise, you would end up with negative angle measurements. So the diagram below shows a right triangle ABC in the plane in the unit circle, centered at the origin. The central angle measures theta as 30, 45, and 60 degrees as shown. So for this first one, it says a unit circle is a circle with radius of 1 unit. What is the length of the hypotenuse in each circle? Label the measure on each circle. So if it is a unit circle, which means the radius is units 1, that means that each of the hypotenuse, which again is across from the right angle, is equal to a value of 1. So it's the hypotenuse. And then it says label the side lengths of the triangles in each circle in exact form using our unit triangle conversions. So if you go back up here, remember we did the unit triangle conversions. This one was for the 45, 45, 90, and this is for the 30, 60, 90. So look across from the 30 is 1/2, and then across from the 60 is root 3 over 2. So across from the 30 is 1/2, and across from the 60, which would be this side, would be root 3 over 2. And then the same thing over here, across from 60, root 3 over 2. Across from 30, which would now be this angle, would be 1/2. And for 45, 45, 90, we get root 2 over root 2 and root 2 over root 2. So now we've labeled those. And then for question 3, it says using the unit circle below on the next page, fill in the degree and radian measures from 0 to 360 and from 0 to 2 pi radians again. So go ahead and do that on your own. So using our what we just talked about a couple minutes ago, see if you can fill it out quickly, and then when you're done, you can on pause to check your work. So go ahead and make sure you pause the video. So of course, those are the values. And so it's really important, like you said, that you can recall this circle very quickly, especially when you get into upper level math like calculus. You'll have to know how to use these, and the longer it takes you to get these values, the longer it'll take you to do calculus problems. Okay, so let's go back up. So we just did that one. For question 4, it says the hypotenuse of each right triangle represents the terminal ray of a central angle which intersects the unit circle at point B. Complete the table to record the sine and cosine values for each angle measure in the first quadrant and the coordinates of the point where the terminal ray intersects the circle. Use your unit triangles to help you. So we just did these. Go ahead and write the radian measures down. We know 0 degrees is 0 radians. 30 is pi over 6. This would be pi over 4, pi over 3, and pi over 2. So going back up here, we're going to use our unit triangles. So again, remember, TOA. So sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. So if we go back to our table, we're going to do cosine first. So cosine is the adjacent. So if I look at this first one here with the 30 degrees, the adjacent is root 3 over 2 over the hypotenuse, which is 1. So the cosine of 30 degrees would be equal to, again, adjacent root 3 over 2 divided by 1, which is just root 3 over 2. If I do the middle one, cosine of 45 degrees, we would get adjacent again over hypotenuse, so root 2 over 2 divided by the 1, which is just root 2 over 2. So the cosine of 45 degrees is root 2 over 2. And over here we have 60 degrees. So the cosine of 60 degrees is equal to adjacent, which is 1/2, divided by 1, which again would just give you 1/2. So down here we can go ahead and start to fill some of this out. So we just did 30 degrees. So we said that 30 degrees was root 3 over 2. 45 degrees we said was root 2 over 2 for the cosine, and 60 degrees we said was 1/2. So what about 0 and 90? So if this is the point 0 degrees means we wouldn't be going, or we'd be at this point right here. So if I'm at 0 degrees, what is this distance? Well, that's the radius, right? And what's the length of the radius? 1. So that means that this point right here would be 1 comma 0. And at 90 degrees, we'd be up here. And again, this is a length of 1 because it's the the hypotenuse is the radius of the circle. That's what I meant to say. So this is over 0 up 1. So how do you find the sine and cosine of that? Notice that for each of these, that would just tell you the value that you're going out. So notice that our cosine value, we have to figure out if it's the x or the y. So let's go ahead and look at, before we do that, let's go ahead and look at the sine of 30, 45, and 60. And that will help you, hopefully, if you don't remember from last year. So if I look at the sine of 30 degrees, the sine is opposite over hypotenuse. So 1/2 and over 1 would be 1/2. So opposite of 30 is 1/2 divided by the hypotenuse, 1. So this would be the sine of 45 degrees is equal to opposite root 2 over 2 divided by 1 because it's a hypotenuse, so root 2 over 2. The sine of 60 degrees is equal to opposite, so root 3 over 2 divided by hypotenuse, which is 1, so root 3 over 2. Notice that the cosine was always the x distance to get to the b. I guess I should use the other color since we did that one in green. So the cosine was this distance here for each of the triangles. And the sine, notice, was this distance because that's the opposite of the angle. And so that means that the cosine, notice it's always on the x-axis, so the cosine is always the x coordinate, and the sine is always the y coordinate. So that means that if the hypotenuse right here is 1, that means the radius is 1, so that means this length is 1. That means that the cosine of 0 is 1, and the sine would be the y coordinate, which would be 0. And then down here, 90 degrees, so the cosine again is the x, so 90 degrees would be 0, and the sine would be 1. And so this was 1/2 root 2 over 2 and root 3 over 2. So the coordinate order pairs are always going to be x comma y. So cosine theta comma sine theta. The cosine of the angle comma the sine. So that gives us 1, 0 for that point. Root 3 over 2, 1/2. And again, we're just writing out the point. So notice root 3 over 2, 1/2 is the point here. So x and y, cosine of the angle, sine of the angle over here. This x and y is root 2 over 2, root 2 over 2. So x and y. So cosine of 45 is root 2 over 2. The sine is root 2 over 2. Looking here, this one was 1/2 comma root 3 over 2. So the cosine of 60 is 1/2. The sine of 60 is root 3 over 2. That's where that's important to know those values. Because they help us fill out our unit circle values. So Jackson conjectured that the coordinates of the point where the terminal ray of the central angle theta intersects the unit circle can always be written as cosine theta comma sine theta. We just actually talked about that, so yes, he's correct. So we just talked about why that was, again, using your triangle. So cosine is always x, sine is always y, because again, you're dividing the hypotenuse. Everything is being divided by 1 on your unit circle. So let's go ahead and now finish labeling our triangle. So again, we learned this last year, but we're just going to go ahead and now fill out our values for the coordinate order pairs. So remember, it's cosine of the angle comma sine of the angle. So first we start off with the 30 degrees, so that means we're looking at this triangle here. So this is 30 degrees. We just said the cosine of 30 degrees, which is the x, was root 3 over 2. And the sine is 1/2. And then the next one we did was using this triangle here. So that's 45-degree angle. So that's root 2 over 2, root 2 over 2, because it comes from that 45, 45, 90 triangle, unit triangle, I should say, because the hypotenuse would be 1. And then the last triangle we're looking at is using this angle as 60 degrees. So we said now that the x coordinate to get here was 1/2, and the y coordinate to get here is root 3 over 2. And then of course this is 1, 0, and then at 90 degrees we have over 0 up 1. So those were the values that we got. And then we talked about last year that, well, all the other quadrants are just reflections. You just have to look at the signs. So in the first quadrant, both sine and cosine are positive because it's positive x, positive y. In this quadrant over here, you have negative, positive, negative x, positive y. Here it would be negative, negative, negative x and negative y coordinates, and down here would be positive x and negative y. So this is going to be positive, negative, 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 and positive, negative. So for this quadrant, we know that this triangle, if we were to reflect it, it would reflect on this side. So that means that this point is going to be the same as this point. The only thing that's going to change are just the signs. So now we would have over here negative 1/2 root 3 over 2. It's hard to write small in these. I zoomed in a little bit to see it. So I'm going to get rid of these triangles here. And then the next one we're going to look at is this triangle here. So if we flip that triangle or reflect it across, notice then that would give me the same point, except for now our x-coordinate is negative root 2 over 2 root 2 over 2. And so of course now we can do this triangle here. So if we reflect that over, it would make this triangle there. So that means that this would be negative root 3 over 2 and 1/2. And of course, if this is 1, 0 here, this is negative 1, 0. And of course, you can also flip or reflect your triangles again into the other quadrants. So this triangle would flip down here, and then it would reflect over here. So that means all those points are going to be the same. The only thing that's changing are the signs. So this is negative root 3 over 2, 1/2. So now it becomes negative root 3 over 2, negative 1/2. And over here, it would be root 3 over 2, because x is positive now, and y is negative, negative 1/2. And then, of course, you could do that with all of the triangles. So 45 triangles are reflected in all the middle. So that means all the middle points are the same, just changing the sign. So this would be negative root 2 over 2, negative root 2 over 2. And over here, this becomes root 2 over 2, negative root 2 over 2. And then we could, of course, do the last values, which are using the 60-degree triangle. So that means all of these are going to have the same values, except the signs are just going to change. So now this is negative 1/2 root 3 over 2, so now it's negative 1/2 negative root 3 over 2. And this point down here isn't with that, but this would be over 0 down 1. And this would be 1/2 negative root 3 over 2. So those are your unit circle values. And again, we talked about this last year, so hopefully that kind of jogs your memory in case you forgot about how to find those values. So again, it's really important that you know your different values on your circles. You need to know the degrees, you need to know the radians, and you need to know the coordinate order pairs for cosine and sine, because then you'll eventually be using these like we did last year. So the cosine of 120 degrees, we then know we would go from here all the way to here. And so that means that 120 degrees, the cosine is the x-coordinate always. So that means cosine of 120 degrees would be negative 1/2. And this allows us to find the exact value solutions, which will help us later when we're doing some other things. And that is it for our Math 3 review on the unit circle.